So, it turns out that something strange is happening to the Earth. Scientists have noticed a shift, an incredibly subtle but undeniable tilt. Now, before you go thinking this is some sci-fi apocalypse scenario, let's be clear, the Earth has always wobbled a little on its axis. It's called axial precession, and it happens naturally over thousands of years. But here's the thing, this time, the shift isn't following the usual patterns. Something is pulling, something is influencing the planet in a way that researchers are scrambling to explain. At first, this tilt was dismissed as a minor anomaly, just another quirk in the delicate balance of planetary motion. But then, data from satellites, astronomical observations, and even deep-sea measurements started piling up. The numbers were undeniable. The tilt wasn't just occurring, it was accelerating. Something was causing the Earth to lean ever so slightly off its usual course, and nobody could figure out why. One of the earliest hints that something was wrong came from measurements of Earth's rotational speed. Normally, our planet completes a full rotation every 23 hours, 56 minutes, and 4.1 seconds. That's pretty consistent. But over the last few decades, we've started noticing tiny fluctuations. We're talking milliseconds, nothing that the average person would ever notice. But in the world of geophysics, milliseconds might as well be alarm bells ringing across the solar system. And here's where it gets weird. These fluctuations in rotation seem to correlate with shifts in the axial tilt. In other words, the planet isn't just tilting, it's behaving in a way that suggests an external force is acting on it. Now, let's talk about the leading theories. Some scientists have suggested that melting ice caps are the culprit. See, when massive amounts of ice melt at the poles, the redistribution of mass affects the planet's balance, kind of like a spinning top shifting slightly when weight is removed from one side. And we know for a fact that the Greenland ice sheet and the Antarctic ice shelves are melting at an alarming rate. Since the early 2000s, trillions of tons of ice have disappeared into the oceans, raising sea levels and altering the weight distribution of the entire planet. It's a compelling explanation, but it doesn't account for everything. Because even when factoring in ice melt, the models don't fully explain the acceleration of the tilt. That's when some researchers started looking underground. Beneath our feet, the Earth's molten core is a churning, roiling mass of liquid iron and nickel. This core is responsible for generating our magnetic field, protecting us from solar radiation, and keeping the planet's internal processes running smoothly. But here's a question: what if something down there is shifting? In 2016, geophysicists noticed that the Earth's magnetic field was behaving strangely. The magnetic North Pole, which used to shift at a steady, predictable rate, suddenly started moving faster. It was racing towards Siberia at an unprecedented speed. Some experts theorize that this could be connected to deeper changes within the Earth's core, mass movements of molten metal that, if large enough, could subtly alter the balance of the planet. And if that's the case, the consequences could be enormous. See, the last time the Earth's magnetic field went through a major shift was about 780,000 years ago, during what's known as the Bruns-Machiyama reversal. Back then, the planet's magnetic poles actually switched places, a process that took thousands of years to complete. But some studies suggest we might be heading toward another reversal, except this time, it's happening faster. If the movements in the core are strong enough to influence the magnetic field, could they also be affecting the axial tilt? And then, of course, there's the more controversial idea, the possibility that an external force is acting on Earth. Something from beyond our planet. One theory points to gravitational interactions with other celestial bodies. We know that the Moon plays a crucial role in stabilizing Earth's tilt, but what if another force, perhaps a distant planet, an undiscovered rogue object, or even a shift in the Sun's activity, was affecting our delicate equilibrium? Some astronomers have speculated about the existence of Planet 9, a hypothetical giant planet lurking in the outer reaches of the solar system. If such an object exists, its gravitational pull could have far-reaching effects, potentially influencing the tilt of planets over long periods. But let's take it even further. Some researchers have suggested that the tilt could be linked to dark matter, one of the biggest mysteries in modern physics. Dark matter makes up about 27% of the universe, but we can't see it, touch it, or interact with it directly. We only know it exists because of its gravitational effects. If Earth is passing through a denser region of dark matter, could it be experiencing a force we simply don't understand yet? It sounds like science fiction, but the reality is, we still don't fully grasp the fundamental forces shaping our universe. And then there's history, because this might not be the first time something like this has happened. Ancient geological records suggest that past civilizations may have experienced unexplained shifts in climate and geography, events that don't entirely line up with what we know about natural cycles. There are old myths, stories passed down through generations, about the sky changing, about the stars moving in ways that confused early astronomers. Some have dismissed these as mere legends, but what if they were observations of real, unexplained phenomena? For now, the world's top scientists are scrambling to understand what's happening. NASA, the European Space Agency, and independent researchers are poring over data, trying to figure out whether this is a temporary anomaly or the beginning of something much bigger. The problem is, the answers aren't coming fast enough. Because if this tilt continues to accelerate, the consequences could be devastating. Now, let's talk about one of the most pressing and controversial theories behind the Earth's unexpected tilt: the rapid melting of the polar ice caps. While the idea might sound straightforward at first, ice melts, water redistributes, and the planet's balance shifts. The full picture is far more complex, unsettling, and quite frankly, a little terrifying when you really dig into the details. Scientists have long known that our planet is not a perfectly rigid sphere. Instead, it behaves more like a dynamic, ever-shifting mass influenced by the movements of water, air, and even deep subterranean forces. But what happens when an enormous amount of weight, millions upon millions of tons of ancient ice, is suddenly removed from one of the most structurally crucial regions of the globe? The answer isn't as simple as rising sea levels. It might actually be throwing off the planet's entire equilibrium, ever so slightly nudging Earth off its natural axis in ways we're only beginning to comprehend. Here's the basic premise: the polar ice caps, particularly in Antarctica and Greenland, have been melting at an alarming rate due to rising global temperatures. This isn't just a matter of a few icebergs breaking off here and there. It's a colossal, unprecedented loss of mass that is fundamentally altering the way Earth distributes its weight. In the last few decades alone, Greenland has lost over 4,000 gigatons of ice, and Antarctica isn't far behind. But the real kicker? This isn't just affecting local sea levels, it's shifting the way Earth spins. Imagine holding a spinning basketball and suddenly shaving off a chunk of material from one side. Even if the change seems relatively small compared to the overall size of the ball, the spin will become slightly wobbly, adjusting in ways that are difficult to predict. That's essentially what's happening to our planet right now, except instead of a basketball, it's a 7,900-mile wide celestial body hurtling through space at over 1,000 miles per hour. And the changes aren't uniform. The Arctic, for example, is losing ice at a much faster rate than the Antarctic, which means the planet isn't just shedding weight evenly, it's becoming lopsided. Scientists have already observed a measurable shift in Earth's rotational axis over the last century, but in recent years, that shift has accelerated. Some experts believe that as ice continues to disappear at an unprecedented rate, the axis could be forced to adjust even more dramatically, leading to potential disruptions in everything from climate patterns to ocean currents. The unsettling part? The effects of this shift may already be underway, and we might not even fully grasp the consequences yet. Some geophysicists have even suggested that an ongoing, slow-motion realignment of the planet's weight distribution could eventually impact the stability of our seasons, subtly altering the way Earth orbits around the Sun. If that sounds far-fetched, consider this. The planet's axial tilt is directly responsible for the changing of the seasons, and even a minuscule adjustment could potentially lead to longer, harsher winters, hotter and more extreme summers, and unpredictable transitions in between. But let's take this even further, because the implications go beyond just shifting weather patterns. If enough ice melts at the poles, it's possible that the redistribution of water could exert pressure on Earth's tectonic plates, influencing geological activity in ways we've never seen before. We already know that ice sheets, particularly in Antarctica, act as a sort of stabilizing force for the land beneath them. When that weight is removed, the ground can rise, a phenomenon known as post-glacial rebound. But in some cases, it doesn't just rise, it shifts. Some scientists have speculated that the rapid loss of ice in certain regions might be subtly altering the pressure dynamics of the crust, which could theoretically trigger more frequent earthquakes or even awaken long-dormant fault lines. Imagine a world where, as the ice melts away, previously stable regions suddenly find themselves plagued by an uptick in seismic activity, all because the delicate balance of weight distribution has been thrown into chaos. And then there's the even more speculative, but no less fascinating, theory: what if the melting of the ice caps is actually linked to deep Earth processes that we don't yet understand? Some researchers have proposed the idea that changes in the distribution of water and ice on the surface could influence the behavior. Think about it: Earth's mantle isn't a static layer of rock, it's constantly in motion, driven by heat and pressure from the planet's core. If an enormous amount of weight is suddenly removed from one part of the planet, could it be enough to disrupt the convective flows beneath the surface? Could this, in turn, be affecting the movement of magma, potentially increasing volcanic activity in certain regions? While this idea is still in the realm of speculation, it's not entirely without precedent. There have been studies suggesting that the retreat of glaciers in some areas has coincided with an increase in volcanic eruptions, particularly in places like Iceland. If the same principle applies on a global scale, it's possible that the ongoing melting of the ice caps isn't just tilting the planet, it could also be stirring the fiery depths below our feet in ways we haven't even begun to comprehend. And that's just scratching the surface of the potential consequences. Because if the melting ice caps are truly influencing Earth's balance and tilt, then the implications for volcanic activity could be far more serious than we realize. To understand why, we need to examine the delicate interplay between Earth's surface and its molten interior. It's easy to think of the planet's crust as a static, unyielding layer of rock, but in reality it's more like a thin shell floating atop a vast, restless ocean of magma. Every shift in surface weight, whether it be the formation of massive ice sheets during an ice age or their sudden melting, can send ripples through the underlying mantle, altering the way heat and pressure build up beneath the surface. This, in turn, has the potential to influence volcanic activity in ways we're only beginning to comprehend. The phenomenon known as post-glacial rebound is well documented. When an ice sheet sits on a section of Earth's crust for tens of thousands of years, it compresses the land beneath it, pushing it down like a heavy weight on a soft cushion. Once that weight is removed, the land begins to rise again, sometimes over the course of centuries, sometimes much faster. But this process doesn't just affect the land, it also changes the stress distribution in the Earth's crust, which can, in some cases, awaken dormant faults and even increase volcanic activity. The best example of this can be found in Iceland, where scientists have observed a direct correlation between melting glaciers and increased volcanic eruptions. As the ice melts, the pressure on underground magma chambers lessens, allowing magma to move more freely and potentially triggering eruptions that might not have occurred for thousands of years under normal conditions. Now apply that same principle on a global scale. If ice loss in Iceland alone is enough to trigger increased volcanic activity, what happens when we're dealing with the rapid disintegration of entire ice sheets in Antarctica and Greenland? These regions sit atop incredibly complex geological formations, including hidden fault lines and even suspected volcanic systems that have remained largely inactive for millennia. Scientists have already discovered more than 90 volcanoes hidden beneath Antarctica's ice, and some geologists believe there could be many more that have yet to be identified. These volcanoes have been buried under ice for so long that their activity has been dampened, held in check by the sheer weight of the frozen landscape above them. But what happens when that ice disappears? Could we be on the verge of a period of increased volcanic activity in some of the most unexpected places on Earth? Some researchers believe that if Antarctica's ice sheet continues to melt at its current rate, it could gradually unburden the landmass to the point where long-dormant volcanoes begin to awaken. This wouldn't necessarily happen overnight, Rather, it would be a slow, incremental process as pressure beneath the crust adjusts. But if even a handful of these subglacial volcanoes were to become active, the consequences could be profound. Volcanic eruptions beneath thick ice sheets don't behave like typical eruptions. Instead of spewing ash and lava into the air, they melt the ice from below, creating vast underground lakes of water that can eventually lead to catastrophic floods when the ice above collapses. Scientists have already identified evidence of massive, hidden reservoirs of meltwater trapped beneath Antarctica's glaciers, and some fear that an increase in volcanic activity could destabilize these fragile systems, leading to sudden, large-scale ice collapses that would dramatically accelerate sea level rise. But Antarctica isn't the only place where this could happen. Greenland, too, has geological mysteries lurking beneath its icy surface. While it's not as volcanically active as Antarctica, some studies have suggested that there may be hidden geothermal activity beneath the ice sheet, which could be contributing to its melting. If the weight of Greenland's ice continues to decrease, could this trigger increased activity in the deeper layers of the crust? Some geophysicists believe that as the land rebounds from the loss of ice, new pathways could open for magma to move upward, potentially leading to small but significant volcanic events in regions where we never expected them. And then there's the even more unsettling possibility. What if the melting of the ice caps is affecting volcanic systems far beyond the poles? Because Earth's crust is a highly interconnected system, shifts in pressure in one region can sometimes lead to unexpected geological activity in another. There's some evidence to suggest that periods of rapid ice loss in Earth's past coincided with increased volcanic activity along the Pacific Ring of Fire, a region known for its powerful earthquakes and explosive eruptions. Could it be that by melting the polar ice caps, we're subtly altering the balance of the entire planet's tectonic system? It's a possibility that some scientists are beginning to take seriously, especially as we witness an increase in unusual seismic and volcanic events around the world. One particularly eerie theory suggests that some of the world's most powerful supervolcanoes, such as Yellowstone in the United States or Campi Flegrei in Italy, could be subtly influenced by these global changes. These massive volcanic systems are already under immense pressure from the molten rock beneath them, and even slight changes in external stress could, in theory, contribute to shifts in their long-term behavior. While it's unlikely that melting ice alone would be enough to trigger a catastrophic eruption, some researchers believe it could be one of many contributing factors in a complex chain of events that eventually leads to increased volcanic activity worldwide. The scariest part? We don't yet fully understand the timeline of these changes. If ice loss is truly altering the planet's balance, shifting weight distribution, and influencing the dynamics of magma movement, then the effects could play out over decades, centuries, or even longer. Or, in the worst-case scenario, they could accelerate in unexpected ways, leading to geological upheavals that catch us completely off guard. The Earth has undergone radical transformations before, and while human civilization has only been around for a tiny fraction of the planet's history, we might be in the midst of witnessing one of those transformations unfold in real time. So, what happens next? If the link between melting ice and increased volcanic activity is real, then we may need to rethink how we predict and prepare for natural disasters. Volcanic eruptions don't just affect the regions where they occur. They can send shockwaves through the global climate, disrupt air travel, and even temporarily cool the planet by releasing massive amounts of ash and sulfur dioxide into the atmosphere. If we're entering an era where volcanic activity is subtly but steadily increasing due to shifts in Earth's weight distribution, then the consequences could be far-reaching and far more unpredictable than we ever imagined. If the melting ice caps and their potential link to increased volcanic activity present one troubling possibility, they are far from the only theory attempting to explain Earth's recent geological and climatic shifts. While some scientists focus on the redistribution of mass due to ice loss, others turn their attention to another equally unsettling possibility: changes deep within the Earth's core itself. Beneath the thin crust upon which we live, an unimaginably vast and complex system of molten rock, swirling metallic currents, and intense heat governs the very stability of our planet. Some researchers believe that recent anomalies in Earth's magnetic field, strange fluctuations in seismic activity, And even unexplained shifts in global climate patterns could be signs that something profound is happening beneath our feet. At the heart of this theory lies the Earth's core, a region that remains largely mysterious despite decades of research. The core is divided into two main layers: the outer core, a turbulent sea of liquid iron and nickel, and the inner core, a dense, solid sphere composed primarily of iron. These two layers do not exist in isolation. Rather, they interact in ways that generate Earth's magnetic field, regulate heat flow, and even influence tectonic activity. However, some scientists now believe that the inner core may not be as stable as previously thought. Recent studies suggest that it might actually be shifting, slowing, or even reversing its rotation relative to the surface, a process that, if true, could have profound consequences for the entire planet. To understand why, consider the fact that the core does not rotate at the same speed as the rest of the Earth. Instead, it moves slightly faster or slower, influenced by the powerful forces of gravity, electromagnetic currents, and the constant transfer of heat between the deep interior and the mantle above it. This differential rotation has been stable for millions of years, but recent seismic data suggests that something may be changing. Some geophysicists claim that the inner core appears to have slowed down or even stopped moving entirely for brief periods before gradually resuming motion in the opposite direction. If this is happening, it raises the unsettling possibility that Earth's entire internal system, its core, mantle, and crust, could be experiencing a kind of imbalance, a subtle but far-reaching shift that might already be manifesting in unexpected ways. One of the most immediate concerns tied to this theory is its potential effect on Earth's magnetic field. The magnetic field is generated by the movement of molten iron in the outer core, and it plays a crucial role in shielding the planet from harmful solar radiation. However, Earth's magnetic field is not static. It fluctuates, weakens, and occasionally undergoes complete reversals, where the north and south magnetic poles switch places. These reversals have occurred many times throughout Earth's history, often taking thousands of years to fully complete. But in recent decades, something unusual has been happening. The magnetic field has been weakening at an accelerated rate, particularly in a vast region known as the South Atlantic anomaly, an area where the field is already so weak that satellites passing over it are at risk of malfunctioning due to increased exposure to cosmic radiation. Could this rapid weakening of the magnetic field be connected to changes in the core's rotation? Some scientists believe so. If the inner core is indeed shifting in unexpected ways, it could be disrupting the flow of molten iron in the outer core, which in turn could be destabilizing the magnetic field. If this process continues, we might be on the verge of witnessing something truly rare, a geomagnetic reversal happening on a much shorter timescale than previously thought possible. Such an event could have serious implications for global infrastructure, as modern technology, particularly GPS systems, relies heavily on the stability of the magnetic field. A sudden, rapid shift could cause navigation errors, interfere with communication networks, and even increase radiation exposure for air travelers and astronauts. But the consequences of an unstable core may extend beyond just the magnetic field. Some researchers speculate that disruptions in the core's movement could also influence the mantle, the thick layer of semi-solid rock that lies between the core and the crust. The mantle is not a uniform, stagnant layer. It behaves more like a slow-moving ocean of molten rock, constantly shifting and convecting over millions of years. This movement is what drives plate tectonics, causing continents to drift, mountains to rise, and earthquakes to occur. If the core's rotation is truly changing, it could alter the flow of heat within the mantle, potentially triggering increased tectonic and volcanic activity across the globe. Some of the world's most geologically active regions, including the Pacific Ring of Fire, have already seen an uptick in seismic events in recent years. Could this be linked to deeper changes occurring in the core? While there is no definitive proof, some geophysicists argue that subtle shifts in Earth's internal heat distribution could be influencing the pressure buildup along fault lines and magma chambers. If this theory is correct, then the increase in earthquakes and volcanic eruptions we are witnessing today may not be isolated events, but rather symptoms of a much larger and more profound transformation happening deep within the planet. And then there's an even more speculative but equally fascinating possibility. What if changes in the core are affecting Earth's rotation itself? While the idea may sound far-fetched, the truth is that Earth's rotation is not perfectly constant. Small variations occur over time due to factors such as the gravitational pull of the Moon, shifts in atmospheric pressure, and even the redistribution of mass on the surface. But if the core's motion is truly experiencing a fundamental shift, then in theory, it could cause minuscule but measurable changes in the length of a day, the wobble of Earth's axis, and even the planet's overall stability in space. Some researchers have pointed to anomalies in Earth's rotational speed in recent years as possible evidence of this phenomenon. While the variations are tiny, fractions of a millisecond, some believe they could be the early signs of a deeper internal process at work. If the inner core continues to change its behavior, it could introduce unpredictable fluctuations in Earth's rotation, potentially affecting everything from climate patterns to weather cycles. After all, Earth's rotation plays a crucial role in shaping atmospheric circulation, ocean currents, and even the movement of jet streams. A seemingly small alteration in the planet's spin could, over time, contribute to long-term shifts in weather patterns, possibly exacerbating extreme climate events such as hurricanes, droughts, and unusual temperature fluctuations. So, if the core is indeed behaving in a way we don't fully understand, what does that mean for the future? Could we be witnessing the beginning of a slow but steady transformation within the planet's interior, one that could have cascading effects on everything from volcanic activity to global climate? Or are these fluctuations merely part of a natural cycle that has occurred countless times before, unnoticed by human civilization because of our relatively short presence on this planet? If the theory that Earth's core is shifting, slowing, or even reversing its rotation is correct, then we may be on the precipice of a profound transformation within the planet, one that could send ripples across the entire geological and atmospheric system in ways we are only beginning to comprehend. While mainstream science acknowledges that the core does not spin in perfect unison with the rest of the Earth, the idea that it could be experiencing an unprecedented disruption raises a cascade of unsettling possibilities. To fully appreciate the gravity of this theory, we must delve deeper into the mechanics of the core itself. Traditionally, it has been assumed that the inner core, composed mainly of solid iron, rotates slightly faster than the planet's surface due to the immense electromagnetic forces generated by the molten iron currents in the outer core. This movement is not merely incidental, it is thought to be a crucial component of Earth's ability to sustain its magnetic field. However, if seismic readings are indeed correct and the core has slowed, halted, or even begun rotating in reverse relative to the crust, then we are dealing with a fundamental shift in Earth's internal equilibrium. One of the most intriguing aspects of this theory is the potential domino effect it could have on Earth's magnetic field. If the core's rotation is slowing down, it could mean that the outer core, the churning, liquid metal ocean responsible for generating the planet's magnetic shield, is also experiencing an energetic imbalance. This could manifest in ways that go beyond a simple weakening of the field. Some researchers speculate that instead of a gradual shift, the magnetic poles might begin to wander erratically, even flipping in ways far more chaotic than past geomagnetic reversals. Historical records of previous pole shifts suggest they take thousands of years to complete, but what if the changes we are seeing today indicate a much more rapid and unstable event? The consequences of such an event could be profound. If Earth's magnetic field were to destabilize, even temporarily, it could expose the planet to increased levels of solar and cosmic radiation. While we often take the protective nature of the magnetosphere for granted, a compromised field could have severe implications, not just for satellites and electrical grids, but for the very stability of the atmosphere itself. Some speculative models suggest that a weakened magnetic field could allow more charged particles from the Sun to reach Earth's upper atmosphere, potentially disrupting global weather patterns in unpredictable ways. Sudden shifts in jet streams, unexplained temperature anomalies, and even long-term climatic changes could be side effects of a deep, unseen transformation happening in the core. But what if the core's instability extends beyond just the magnetic field? Some theorists suggest that if the inner core's movement is changing in a fundamental way, it could send pressure waves outward, subtly affecting the mantle and, by extension, the crust itself. This could provide a startling explanation for the seemingly random surge in seismic and volcanic activity observed in recent years. While mainstream geology attributes increased earthquakes and eruptions to standard tectonic processes, this theory suggests that something deeper is at play, something that originates not from the crust, but from the very heart of the planet. Imagine, for a moment, a scenario in which the core's altered motion affects the flow of heat in the mantle. The mantle, despite being a semi-solid layer, behaves almost like an ocean of slow-moving rock currents, transporting heat from the deep interior to the surface over geological timescales. If changes in the core's rotation are disrupting this heat flow, then entire sections of the mantle could become thermally imbalanced, leading to pockets of increased pressure and instability. This could theoretically explain why certain volcanic regions, such as the Pacific Ring of Fire, seem to be experiencing heightened unrest. Further complicating the picture is the possibility that these changes are not limited to the deep interior. If the core is truly shifting, could it be subtly affecting Earth's rotation itself? While the idea might seem extreme, it is not without precedent. Scientists have long known that the redistribution of mass within the planet, whether through glacial melting, tectonic movements, or shifts in the core, can influence the planet's rotational speed. If the core's movement is indeed slowing or reversing, it could introduce subtle but measurable changes in the length of a day, the tilt of Earth's axis, or even the planet's orbital stability over long periods. One of the most fascinating aspects of this theory is its potential to explain anomalies that have puzzled scientists for years. For instance, in recent decades, there have been unexplained fluctuations in Earth's rotation rate, tiny variations that, while minuscule, could be early indicators of a much deeper shift occurring within the planet. Could these fluctuations be the first signs of a correlated event? Some researchers believe so, arguing that the energy imbalance created by a slowing or reversing core could manifest in ways we have not yet fully grasped. If this theory holds weight, then what we are witnessing today may not be a simple cycle of natural variation but the early stages of a planetary transformation, one that could have profound consequences for the future. The unsettling question remains, is this process accelerating? If the core's motion is indeed changing at a rate faster than previously thought, then we may be entering uncharted territory, a period of geological instability unlike anything recorded in human history. Of course, without direct access to the core, much of this remains speculative. But the pieces of the puzzle, anomalous seismic readings, a weakening magnetic field, unexplained fluctuations in Earth's rotation, suggest that something is happening deep beneath our feet. Whether this is part of a long-term cycle or the beginning of something unprecedented remains to be seen. But one thing is certain: if Earth's core is truly undergoing a dramatic shift, then the effects could extend far beyond the realm of geology, influencing everything from climate to global stability in ways we are only beginning to understand. If the shifting core theory presents a vision of internal instability, then another equally compelling hypothesis takes us in a different direction, one that looks not beneath our feet, but above our heads. While changes deep within the Earth could be influencing the surface, what if the driving force behind the anomalies we are witnessing originates from beyond our planet altogether? Some researchers and theorists have begun considering an unsettling possibility that an external cosmic force, something far outside the realm of traditional geophysics, may be exerting a growing influence on Earth's delicate balance. At first glance, the idea may seem speculative, even outlandish. After all, Earth has existed within the solar system for billions of years, constantly subjected to the gravitational pull of the Sun, the Moon, and the distant tugs of other planetary bodies. The celestial mechanics that govern these interactions are well understood, and for the most part, our planet remains in a predictable and stable orbit. But what if that stability is being disrupted in ways we do not yet fully comprehend? What if an unseen astronomical phenomenon is quietly interfering with Earth's internal dynamics, triggering shifts in tectonic activity, climate patterns, and even the electromagnetic field? One leading theory proposes that a hidden celestial body, a rogue planet, a dense cluster of dark matter, or even an undiscovered massive object on the fringes of the solar system, is exerting gravitational stress on Earth. This concept is often linked to the long-debated Planet 9 hypothesis, which suggests that an unseen giant planet, lurking somewhere in the far reaches of the Kuiper Belt, could be subtly influencing the orbits of known celestial objects. While the existence of such a planet remains unconfirmed, the idea that an external gravitational force could be affecting Earth is not beyond the realm of scientific possibility. The gravitational influence of a massive unseen body could be manifesting in ways that are not immediately obvious. Consider, for example, the growing evidence that Earth's rotation and axial tilt are not as constant as once believed. While small wobbles and fluctuations in rotation have always existed, recent anomalies in the planet's spin rate and pole drift suggest that some external force may be acting upon it. Could the gravitational pull of an undiscovered celestial body be subtly altering Earth's orientation, leading to increased stress within the crust and mantle? If so, this could provide a compelling explanation for the unusual seismic activity, the unexplained warming of certain ocean currents, and even the irregular behavior of the magnetic field. Beyond gravity, there is also the possibility that an increase in cosmic radiation, whether from an approaching celestial object, a distant supernova, or changes in the sun's activity, is influencing Earth's internal and atmospheric processes in ways we have yet to fully understand. Cosmic radiation, though largely shielded by Earth's magnetic field and atmosphere, has been known to impact climate cycles on geological timescales. Some researchers have even suggested that past mass extinctions and ice ages were triggered, at least in part, by sudden spikes in cosmic energy reaching the planet. One particularly intriguing theory ties these ideas together, suggesting that the solar system itself may be moving through a region of space with a higher concentration of interstellar energy. If our planet is currently passing through an area of intensified cosmic radiation or interacting with previously unknown gravitational anomalies, it could explain why we are seeing an uptick in extreme natural phenomena. This hypothesis aligns with some recent scientific observations that suggest Earth's upper atmosphere is experiencing unexplained fluctuations in energy levels, possibly linked to increased cosmic ray penetration. Taking this idea further, some have proposed that these cosmic forces could be affecting Earth's core directly, altering its thermal dynamics in ways that lead to increased volcanic and seismic activity. If charged particles from space are interacting more intensely with the planet's inner layers, they could be contributing to subtle changes in heat distribution, causing shifts in mantle convection patterns and leading to unpredictable geophysical consequences. While mainstream science remains cautious about such claims, the pieces of the puzzle are compelling. If Earth is indeed being influenced by an external force, whether gravitational, electromagnetic, or something more exotic, then the implications are profound. It would mean that our planet's current period of instability is not merely a result of internal cycles or human activity, but part of a much larger cosmic event. It could also suggest that these changes are not temporary fluctuations, but rather the beginning of a more significant transformation, one that could redefine our understanding of Earth's place in the universe. One of the most alarming potential effects of this cosmic influence could be a significant disruption in Earth's magnetic field, a phenomenon that might not only affect technology and infrastructure but could also have profound consequences on life itself. The Earth's magnetic field, which acts as a protective shield against harmful solar and cosmic radiation, is critical to maintaining a stable environment for life. Without it, our planet would be exposed to higher levels of radiation, which could disrupt everything from satellite communications to human health. However, if external cosmic forces, whether gravitational disturbances or increased cosmic radiation, are indeed affecting the Earth's core, they might cause unpredictable fluctuations in the magnetic field, leading to serious consequences for both the planet and its inhabitants. The first visible consequence of such disruptions might be the weakening or shifting of the magnetic poles. While the magnetic poles have shifted throughout history, they are typically slow-moving processes that occur over long periods of time. A sudden acceleration in this movement, perhaps triggered by an unseen cosmic influence, could result in an abrupt pole reversal, a phenomenon where the magnetic north and south poles switch places. Though pole reversals have occurred in the distant past, they are extremely rare and could carry serious ramifications for life on Earth. A rapid magnetic pole reversal could have catastrophic consequences for technological systems that rely on the stability of the magnetic field. Modern life is deeply intertwined with technology that depends on the Earth's magnetic field for navigation and communication. GPS systems, for example, rely on satellites that are constantly adjusting their position based on magnetic fields. A disturbance in this delicate system could cause widespread disruptions in GPS services, making navigation difficult or even impossible. Commercial flights, shipping routes, and military operations could be severely impacted, as pilots and sailors often rely on magnetic compasses to navigate, and GPS is frequently used for real-time positioning. In addition to navigation, our telecommunications infrastructure could face significant challenges. Satellites in orbit rely on Earth's magnetic field to protect their sensitive electronics from radiation. If the magnetic field were to weaken or fluctuate unexpectedly, satellites might be exposed to higher levels of cosmic radiation, potentially damaging their components and rendering them inoperable. The loss of even a small number of satellites could lead to a breakdown in communication systems, from internet connectivity to emergency services. Military communications and national security could also be at risk, as many defense systems depend on the ability to transmit signals and maintain communication in real time. But the effects wouldn't be limited to technology alone. Increased exposure to cosmic radiation, especially during periods when the magnetic field is weaker, could have serious consequences for human health. Earth's atmosphere and magnetic field work together to filter out harmful radiation from the sun and deep space, shielding life on the planet from potentially harmful doses of solar wind and cosmic rays. If the magnetic field were to become disrupted or weakened, this protective barrier could falter, allowing higher levels of radiation to reach the surface. The potential effects of increased cosmic radiation on human health are profound. Over time, higher levels of radiation could increase the risk of cancer and other radiation-related illnesses. The long-term exposure to cosmic rays has been linked to genetic mutations, which could be passed down to future generations. Additionally, the heightened radiation could have immediate consequences for human biology, affecting the nervous system, cardiovascular system, and even the immune system, making people more susceptible to illness. Even more concerning is the impact such exposure could have on vulnerable populations. Pregnant women, children, and the elderly are particularly susceptible to the negative effects of radiation, and a disruption of the magnetic field could amplify these risks. Furthermore, astronauts in space, who are already exposed to higher levels of radiation, would face even greater threats to their health, and space travel could become far more dangerous. The potential for radiation-induced illnesses would add an entirely new layer of concern for space exploration, as space agencies would need to account for new dangers to the health and safety of astronauts. Beyond human health, the disruption of the magnetic field could also have cascading effects on other forms of life. Some animals, such as migratory birds, sea turtles, and certain species of fish, rely on the Earth's magnetic field to navigate during migration. A sudden shift or weakening of the magnetic field could disorient these species, leading to disorientation in migration patterns, disrupted breeding cycles, and a potential decrease in population numbers. The delicate balance of ecosystems that depend on these migratory patterns could also be threatened, causing ripple effects throughout the food chain. As if all of this weren't enough, the potential effects on Earth's atmosphere could also pose a serious threat to the planet's habitability. The magnetic field, by deflecting charged particles, helps to prevent the solar wind from stripping away the atmosphere. Without this protection, the atmosphere could gradually thin, leading to a breakdown in the conditions that sustain life. The loss of atmosphere would result in a gradual but inexorable shift toward harsher conditions on Earth. While this process would likely take thousands or even millions of years, the potential for irreversible damage would be a cause for concern, as it would fundamentally alter the environment in which all life exists. Another potential effect that could arise from these cosmic disruptions is the dramatic impact on Earth's climate, specifically the intensification of extreme weather events. Climate systems on Earth are incredibly sensitive to subtle changes in atmospheric pressure, ocean currents, and even solar radiation. If the theory of increased cosmic radiation or gravitational disturbances holds true, it could lead to a cascade of changes in these interconnected systems. The increase in cosmic radiation, for instance, might influence the behavior of cloud formation, ocean circulation, and atmospheric pressure systems, all of which could combine to create more extreme and unpredictable weather patterns across the globe. The first noticeable consequence could be an increase in the intensity and frequency of storms, including hurricanes, tornadoes, and thunderstorms. The energy provided by cosmic radiation could potentially alter the dynamics of the atmosphere, making it more conducive to the development of severe weather systems. Storms that once followed predictable seasonal patterns could become erratic, shifting unpredictably in both timing and strength. In particular, tropical regions could see an uptick in the formation of powerful hurricanes fueled by warmer sea surface temperatures, a phenomenon that is often exacerbated by changes in atmospheric pressure systems. Hurricanes, which thrive on warm ocean waters, could become more frequent and intense as higher levels of radiation could influence both the atmospheric pressure over the oceans and the temperatures of the waters themselves. These storms, already capable of devastating communities, could grow in size, packing even stronger winds, higher storm surges, and more torrential rains. Coastal regions, already vulnerable to rising sea levels and frequent flooding, could face an even greater threat. Not only would these storms cause immense destruction, but their unpredictable nature would also make it harder for governments and emergency responders to plan and mitigate their effects. Alongside hurricanes, tornadoes could also become more frequent and powerful. The altered atmospheric conditions might lead to greater instability in the atmosphere, creating conditions more conducive to the formation of tornadoes. These storms, which often appear with little warning, could become more destructive, particularly in areas that have historically been less prone to such extreme weather. The unpredictability of their occurrence would make it difficult for residents to prepare, leading to higher casualties and greater damage to infrastructure. Thunderstorms themselves could undergo a dramatic shift, becoming far more volatile and intense. These storms could spawn more frequent lightning strikes, heavier rainfall, and even localized flash flooding. While thunderstorms are common, their severity could increase, posing a greater risk to agriculture, property, and public safety. This could also lead to disruptions in power grids, with more lightning-related outages, and create challenges for communities that are already dealing with unpredictable weather patterns. Moreover, the effects wouldn't be limited to storm systems alone. Cosmic disturbances could also influence the climate in subtler, but no less impactful, ways. A shift in the global wind patterns could trigger significant changes in rainfall distribution, potentially causing droughts in some regions while leading to excessive rainfall and flooding in others. The agricultural industry would be one of the first to feel the strain, as crops rely on predictable weather patterns. Areas that once thrived with consistent seasonal rainfall might experience droughts that last for years, while other regions might be subjected to floods that wash away crops and render farmlands unproductive. In addition to altering precipitation patterns, global temperatures could also be impacted by these cosmic changes. If cosmic radiation influences cloud cover or the behavior of aerosols in the atmosphere, it could either amplify or diminish the effects of climate change. On the one hand, the interaction of radiation with the atmosphere could cause global cooling, potentially counteracting some of the warming effects of greenhouse gases. On the other hand, this same cosmic influence could amplify the warming effect, leading to more extreme temperature fluctuations. In either scenario, the consequences of these temperature changes would be felt by ecosystems around the world. Species that rely on specific temperature ranges could find themselves at risk. Polar regions, already facing dramatic shifts due to global warming, could experience even faster changes, resulting in the collapse of ice sheets, the migration of species, and the destruction of delicate ecosystems. On the other hand, regions that are typically warmer could see an exacerbation of drought conditions, leading to desertification and the loss of arable land. The effects on agriculture, particularly in regions that rely on stable weather for planting and harvesting, could be catastrophic. The unpredictability of weather systems could make it nearly impossible to plant crops, resulting in reduced yields and food shortages. The global food supply chain, already under pressure from various environmental challenges, could face an additional strain, leading to higher food prices and increased economic instability. Moreover, these weather changes could create a ripple effect, leading to large-scale migrations of people. As certain areas become uninhabitable due to extreme weather, populations might be forced to relocate, creating climate refugees. This could lead to tensions between nations, as resources become scarcer and countries grapple with the influx of displaced populations. The added strain on cities and infrastructure could exacerbate existing social and economic problems, potentially leading to conflicts and unrest. As a result, this scenario would not only affect the natural world but would also have far-reaching consequences for human society. Increased competition for resources, the breakdown of infrastructure, and the rise of social and political tensions could reshape the global landscape in ways we have yet to fully understand. What was once a predictable climate system could become one of constant volatility, forcing humanity to adapt to an ever-changing world. While this theory remains speculative, the potential for such disruptions serves as a stark reminder of how fragile our relationship with the environment truly is. Even the slightest cosmic influence could tip the balance, creating a cascade of effects that alter the very fabric of life on Earth. As the threat of cosmic disturbances and the resulting climate upheavals loom larger on the horizon, it becomes increasingly important for humanity, governments, businesses, and individuals alike, to come together and develop a comprehensive approach to address these potential crises. While the precise nature of these cosmic disruptions is still speculative, the scale and potential impact of such an event warrant immediate action on multiple fronts. This collaborative effort could focus on prevention, mitigation, and adaptation strategies, working together to protect vulnerable populations and ecosystems. One of the first areas that would require urgent attention is global scientific research. Governments around the world, in collaboration with private enterprises and academic institutions, would need to pour substantial resources into investigating the causes and potential trajectories of these cosmic disturbances. Establishing international partnerships, similar to those seen in large-scale projects like the International Space Station, could foster shared knowledge and a more unified approach. A global research initiative, possibly spearheaded by organizations such as the United Nations or the World Health Organization, could work to build predictive models of cosmic events and assess their possible impacts on Earth's atmosphere and climate systems. This international scientific collaboration could lead to the creation of a global monitoring system. Satellites designed to track cosmic radiation levels, magnetic fluctuations, and changes in the solar wind could provide real-time data to help scientists detect early warning signs of cosmic disruptions. These satellites could also serve as a method of monitoring the planet's atmosphere and oceans for any irregularities caused by cosmic events. With better monitoring, governments would be able to issue advance warnings to populations at risk, much like how meteorological organizations predict weather events today. Early detection would be critical for saving lives, allowing citizens to evacuate or take precautions in advance of potentially catastrophic storms or extreme weather events. On the governmental level, countries could invest in infrastructure resilience to ensure that critical systems, such as power grids, communication networks, and water supplies, are less susceptible to the impacts of extreme weather. This could include the hardening of electrical grids to withstand stronger storms, as well as reinforcing flood protection infrastructure in coastal and riverine areas. Governments might also consider investing in new forms of green technology, which could not only mitigate the potential impacts of climate change, but also serve as a buffer against the unpredictable effects of cosmic disturbances. The development of renewable energy sources, like solar, wind, and tidal power, could be crucial in reducing reliance on vulnerable power grids that could be easily damaged during extreme weather events. In parallel, national governments could create policies to incentivize the reduction of carbon emissions and promote sustainability. While the focus of this would still be on combating climate change, Such policies could also serve as a proactive measure against the broader environmental disruptions caused by cosmic disturbances. By reducing greenhouse gases and increasing environmental stewardship, governments would be working to ensure that Earth's systems are more resilient in the face of whatever cosmic challenges lie ahead. Regulations might be introduced to limit deforestation, protect wetlands, and restore natural habitats, all of which help maintain the delicate balance of Earth's climate system. Moreover, public awareness campaigns could play a crucial role in preparing individuals for the unpredictable weather patterns and extreme events that may arise. Governments could collaborate with media outlets, educational institutions, and NGOs to inform the general public about the potential impacts of cosmic disturbances and the ways they can contribute to resilience efforts. Local communities could be educated on the importance of disaster preparedness, teaching them how to create emergency plans, build disaster kits, and understand early warning signs of extreme weather. This grassroots-level education could be pivotal in ensuring that people are ready to take action in the event of a sudden, devastating storm or other climate-related catastrophe. Private companies, especially those in the technology and energy sectors, could also play a significant role in developing new innovations to help mitigate the effects of cosmic disturbances. The rise of climate engineering technologies, such as geoengineering, could be explored as a potential solution to reverse or counteract the damage caused by cosmic radiation. Though controversial, the idea of altering Earth's atmosphere to reflect sunlight or absorb excess radiation could be considered as a potential tool to stabilize the climate. While such solutions would need to be studied carefully, private companies with expertise in aerospace and atmospheric science could collaborate with government agencies to test the feasibility of these methods. Additionally, businesses involved in infrastructure development could look into constructing cities and buildings designed to withstand extreme weather conditions. Innovations in architecture could lead to the creation of climate-proof structures that are resistant to flooding, tornadoes, or extreme temperatures. From waterproofing buildings to designing flexible, wind-resistant structures, companies could spearhead the development of infrastructure that can endure the kind of unpredictable conditions that cosmic disturbances might bring. These efforts would not only protect people but also preserve valuable resources, ensuring that societies can continue functioning even under extreme conditions. Another area where businesses could make a significant impact is in the agricultural sector. As climate disruptions threaten food security, companies could invest in developing crops that are more resilient to drought, floods, and temperature extremes. Advances in genetic engineering might yield crops that can thrive in harsh conditions, or new agricultural techniques, such as vertical farming or hydroponics, could help ensure food production continues despite shifting weather patterns. By working with governments and international organizations to build global food security networks, companies could ensure that populations have access to nutritious food even during times of environmental upheaval. On a more local level, individuals can contribute by adopting more sustainable practices in their everyday lives. While this won't directly prevent cosmic disturbances, reducing carbon footprints, conserving water, and promoting sustainable living can collectively contribute to the resilience of Earth's climate systems. Grassroots efforts, such as local tree planting programs, community-based clean energy projects, and sustainable agriculture practices, could all have a compounding effect on mitigating the long-term impacts of cosmic disruptions. As we've explored throughout this journey, the potential effects of cosmic disturbances on our planet are as vast and unpredictable as the universe itself. From the threats posed by melting ice caps to the possibility of altered magnetic fields, extreme weather events, and shifting ocean currents, we've seen how much of our world is vulnerable to cosmic influences beyond our control. While these theories remain speculative, the reality of their potential consequences demands that we begin to think seriously about our planet's future and the steps we can take to mitigate and adapt to these challenges. But in the face of uncertainty, one thing remains clear: humanity's resilience and ability to innovate will play a critical role in how we navigate the storms, both literal and figurative, that lie ahead. Whether through scientific research, international cooperation, or advancements in technology, we are capable of taking proactive steps to minimize the risks of these cosmic events and safeguard our way of life. Governments, businesses, and individuals alike all have a stake in ensuring the planet remains a habitable place for future generations. Theories may evolve, new information may surface, and the true extent of these cosmic disturbances might become clearer over time. But the question is not whether these events will occur, but how prepared we will be when they do. Will we have the foresight to implement the necessary policies? Will we invest in the technology that can help us adapt and recover? And will we be able to work together as a global community to face whatever challenges come our way? One thing is for certain, this is just the beginning of an ongoing conversation, one that we must continue to engage with as we move forward. The choices we make today will determine how resilient we are in the face of the unknown, and what kind of legacy we leave for future generations. Thank you for staying with us as we explored these fascinating, albeit unsettling, possibilities. As we continue to uncover the mysteries of our planet and the universe beyond, it's crucial that we keep asking the hard questions and push ourselves to find innovative solutions. The more we learn, the better prepared we will be for whatever challenges may arise. We hope this video has sparked your curiosity and encouraged you to think critically about the future of our planet. If you enjoyed this deep dive into the cosmic forces shaping our world, don't forget to press that subscribe button so you never miss out on the latest theories and developments. Join us on this journey as we continue to explore the unknown, challenge conventional thinking, and prepare for the future together. Your support means the world, and we can't wait to bring you more content that sheds light on the most pressing questions of our time. Stay curious, stay informed, and most importantly, stay prepared.